Hey everyone, and welcome! So you're getting ready for your SPM Chemistry exam, and the topic of glass keeps popping up, right? Well, you've come to the right place. We are going to make this topic absolutely crystal clear so you can walk into that exam feeling totally confident. Okay, before we get started, here's a pro tip from me to you. The best way to learn is by doing. So after this, go ahead and scan this QR code or just pop over to MCQ SPM.com. You can practice with tons of past year questions. Seriously, it's a total game changer for your revision. All right, so what's the big deal with glass anyway? Why does it trip so many students up in exams? Honestly, it really just comes down to one thing: confusion. You've got all these different types of glass, and it's just so easy to mix up their properties. And you can bet that the exam questions are designed to catch you out on that. So let me ask you this. Which type of glass can you stick over a Bunsen burner without it shattering? And which one is used to make those really sparkly decorative prisms? If you're scratching your head right now, don't even worry. By the end of this, you're going to be a total pro. Ready to meet the main characters of our story today? We're going to focus on the 4 key players in the world of glass that you absolutely need to know: fused silica, soda lime, borosilicate, and lead crystal. Let's get to know them. First up, we've got fused silica glass. Think of this one as the purest of the group. It's basically just pure silica, nothing else added. This purity gives it a crazy high melting point and makes it super tough against sudden temperature changes. That's exactly why it's perfect for high-precision stuff like telescope lenses. Next is the one you see literally every day: soda lime glass. This is your standard glass for things like bottles and windows. By adding soda and limestone to the silica, we can melt it at a much lower temperature, which makes it way cheaper and easier to shape. But there's a catch. It does not like sudden temperature changes. Not at all. Now meet the lab champion, borosilicate glass. You probably know it by its brand name, Pyrex. So what's its secret? It's all about the boron oxide. That's the magic ingredient that gives it a super low expansion coefficient. What that means is it can go from boiling hot to cold without shattering. And that, of course, is why it's an absolute must-have for lab beakers and even your kitchen cookware. And last, but definitely not least, we have lead crystal, the real star of the show when it comes to decoration. Adding lead oxide makes this glass heavy, dense, and gives it this incredible sparkle. It's a total pro at bending light, which is why it's the perfect choice for fancy decorative items and light-splitting prisms. Okay, so you've met the 4 main types of glass. But for your exam, it's not enough to just know what they are. You need to know why they behave the way they do. Understanding their properties is the absolute key to nailing those questions. This slide just shows it all perfectly, doesn't it? It's the difference between our lab champion and our everyday glass. Borosilicate has a low expansion coefficient, meaning it barely changes size when heated. It can handle the shock. But soda lime glass? It expands a lot, and that's why it's so prone to cracking. So now you know the actual science behind why pouring a hot drink can sometimes shatter a cheap glass. In this right here, this is why lead crystal is so beautiful. It has what we call a high refractive index. All that means is that it's fantastic at bending light. The more it bends the light, the more sparkle you get. That's why it's the go-to for anything that needs to look brilliant, from chandeliers to fancy glassware. All right, that's enough theory. Let's actually put this knowledge to the test. We're going to take a real past year SPM question, and I'm going to walk you through a foolproof method for breaking it down and getting the right answer. So here's our challenge. It's a question about photochromic glass. You know, the kind in glasses that magically darken when you step into the sun? The question is asking, what's the chemical that makes that happen? Okay, let's use our 3-step strategy. Step 1, identify the keywords. Easy: photochromic and darkens in sunlight. Step 2, access what you know. What kind of chemical reacts to light? Think back, silver halides, right. Step 3, select the answer. The substance has to be silver chloride. The UV light from the sun causes a reaction that turns silver ions into silver atoms, which makes the glass dark. Simple as that. Boom, question solved. So, now that you've got the concepts down, it's time to pull it all together. This next slide, this is your secret weapon for revision. Think of it as your ultimate glassy cheat sheet. This table right here is your new best friend. I'm serious, you should pause and just let this sink in. It connects every single thing we've talked about. See how it links each glass type to its special ingredient, its most important property, and a classic example you'd see in an exam. Fused silica, pure, high melting point, for telescopes. Soda lime, adds soda and limestone, high expansion, for your everyday bottles. Borosilicate, the secret is boron oxide for low expansion, making it our lab champion. And lead crystal. Lead oxide gives it that high refractive index and sparkle. If you can master this table, you'll be unstoppable. So, you're all set for your exam? But here's a final thought to leave you with. That humble material, silica, is the building block for so much of our modern world, from the fiber optic cables that connect us all to maybe even the superconductors of the future. So, what's next for glass? The possibilities are pretty much endless. Always keep asking those questions. You'll go far. Good luck.